vertices of an adjacency matrix of graph G whose value is 1. Okay. Now we will try to color each of the vertex, and just to call and define the process next underscore color and an argument k. The function takes an index of the kth vertex, k is a vertex number, which to be colored. And the first we assign the color 1 to the kth vertex, then we check whether it is connected to any of previous k minus 1 vertices using backtracking. If connected, then assign a color xi plus 1, where xi is the color of ith vertex that is connected with k vertex. Then আমরা যদি একটা example draw the example and explain it. Explain, I'm just to say V0 vertex, another V3. Now V1 and V2. So the 4 vertices the 5 edges. Let first the number of edges. How many number of vertices? The number of vertices n equal to, say, n equal to 5. 4. Number of vertices 4. And number of edges equal to number of edges equal to 5. At first to decide 5. And just to declare a 2-dimension array whose content whose representation of in a algorithm that for adjacency matrix. Say G is a graph, is a 2-dimension graph. Say 2-dimension graph, the size is say 10 and 10. 10 and 10. Okay. G equal to 10 and 10. Number of rows 10 and column 10. Now, say what is the adjacency matrix? Adjacency matrix. I'm just to zero, 1, 2, 3, 0, 1, 2, 3. There are, because in this graph the number of vertices are 4. Say 0, 1, 2, 3. Adjacency matrix, the order of adjacency 4 into 4, because the number of vertices is 4. So 4 into 4 is the order of adjacency matrix. The initially all location is actually initial all location 0. আমরা প্রথমে সমস্ত লোকেশনগুলোকে 0 করে দেব। Okay, all location 0. After that, the adjacency matrix of a graph G and the integer numbers আমরা 0 দিয়ে fill up করেছি। Now to start the how many number of edges are there? The 5 number of edges are there. 0 0 0 0 1 0 v0 to v1 the edge is there. তাহলে v0 to v1 এই v0 to v1 এখানে edge যেহেতু থাকে সেজন্য আমি এখানে কি করব না আমরা এখানে 1 অ্যাড করব। 0 is replaced by 1, এখানে আমি 1। তো similarly 1 0 1 0 1 0 is also 1, 1 0 is also 1, and another 0 3 0 3 is there, vertex 0 to vertex 3, vertex 0 থেকে vertex 3 এই জায়গাতে কি আছে এখানেও এজ আছে সেজন্য আমি এখানেও কি করছি 1 ফিট করব। আর সিমিলারলি 3 0 এই জায়গাতে এখানেও আমি কি করছি 1। and after that v1 to v0 v1 to v0 1 is there, আবার v0 থেকে v3 v1 থেকে v3 v1 থেকে v3 v3 এখানে এটা 1 1 and v3 থেকে v1 আর v3 থেকে v1 এখানে 1 and v1 to v2 v1 থেকে v2 এখানে 1 and v2 থেকে v1 এখানে 1 and v2 থেকে v1 to v1 1, আবার v2 থেকে v3 থেকে v3 এখানে 1 and v3 থেকে v0 1, v3 থেকে v1 1, v3 থেকে v2 1 and no self loop v3 to v3 adjacency matrix for the graph. এই গ্রাফটার adjacency matrix হলো এটা। তাহলে how many edges are there? এটার লজিক কি হবে? It's very simple logic. আমরা একটা জাস্ট একটা ফর লুপ আমরা একটা ফর লুপ ক্রিয়েট করব। and just paste for I equal to 0 to EG is a age, number of age minus 1. Okay. And value, say read U is a source vertex, V is a destination vertex for the age, and GUV equal to 1 and GVU equal to 1. Because this type of adjacency matrix is a symmetric adjacency matrix. The symmetric, আমরা যদি দেখি এই diagonally আমরা diagonal all values are 0. এখানে যে ভ্যালু গুলো আছে ঠিক সেম, the lower triangular to same value আছে. This type of adjacency matrix is known as the symmetric adjacency matrix. এরপরে আমরা the graph representation is over. Then the next step, I'm just to call the one important function. The name of the function is next color. Okay. The next color function, I'm just to call the actually the algorithm step 2, the next to next underscore color. Zero is the starting vertex, and comma, and n is a number of vertices. The coloring each vertex, and 0 is the starting vertex. Remember it. Okay. After that, define the procedure. Next color function. Whose argument, say suppose k is a kth vertex and n is a number of vertices. There is actually this function is actual purpose is the check and find unique color. Okay. Steps is first, if k value of k is equal to number of vertices, যদি k এর ভ্যালুটা যদি number of vertices এর সঙ্গে সেম হয়ে যায়, say suppose the value of k is a 4, value of k is 4, the number of vertices, the number of vertices is 4 and k value is equal to 4. তাহলে কি হচ্ছে না, just to call the display function, that is the coloring is over, the all vertices are colored. Okay. এখানে কিছু যেহেতু আমি k start from, the k is actually here start from and just k start from value 0, where k equal to n minus 1. Then okay. I'm just to display to call the display function whose argument n is a number of vertices. Okay. N is a number of vertices. And step 2, solution vector. Now at first to create a solution vector xk, the starting value of k is 0, x is a one dimension array, that is a solution vector whose contain the color number. Okay. So k equal to 0, k array xk, k is a vertex number, x equal to 1 the first color, it's red, the representation, the coloring the vertex with color 1 is a red. So, now next, the step 3. Step 3, just and using the for loop. For loop. For I equal to 0, for I equal to 0 to k minus 1. Do if j I k not equal to 0 and xk equal to xi, then the xk equal to xi plus 1. Xi plus 1. The xi is also, suppose xi location is 0 is there. তাহলে 0 plus 1, that is 2. কখন হবে না যখন যে xi ik not equal to 0, কেননা gik not equal to 0, g তে কি আছে, g তে 1 or 0, 1 and 0, তা 1 লোকেশন গুলো কি রিপ্রেজেন্ট করছে না, 1 লোকেশন গুলো হচ্ছে এজ দেয়ার, অ্যাডজাসেন্সি এজ। তাহলে যখন নট ইকুয়াল টু 0 পাচ্ছে, নট ইকুয়াল টু 0 and xk, the value of xk, this is initially is the value of xk is suppose ওর মধ্যে আছে কি ভ্যালু, xk এর মধ্যে ফার্স্টে আমরা অ্যাসাইন করেছি xk is 1, কোন ইন্ডেক্সে না আমরা 0 তে, 0 ইন্ডেক্সে ওর ভ্যালু অ্যাসাইন করেছি 1। তাহলে ইন্ডেক্স নাম্বার here is 0 1 2 3, এগুলো কি না, এগুলো x এর লোকেশন, x লোকেশন। তাহলে আমরা প্রথমে 0 ইন্ডেক্সে, this is the x এ 1 আছে 0 ইন্ডেক্সে, তাহলে এখানে যদি নট ইকুয়াল টু 0 হয়, সে ফর i equal to 0 0 to k minus 1, the value of k, the value of k starting initially 0 0 minus 1, তাহলে এটা হবে না। যখন সে সাপোজ এ ভ্যালু k value of k is 1, তাহলে i equal to 0 to k minus 1, 1 minus 1 0, yes, the for loop condition is true. তাহলে x I k, the value of I is 0, k is 1 0 1 0 1, not equal to 0, yes, not equal to 0 1, and xk, what is the value of xk, the value of k is 1, then x1 x1 equal to xi, the I is 0, তাহলে xi মানে x0, xk, the value of xk is 1, মানে x1 equal to xi, যদি না হয় তাহলে ফলস, তাহলে লুপ কন্টিনিউ হবে। ওকে, otherwise if this condition is true, then assign xk equal to xi plus 1, the previous value 1 যদি থাকে তার সঙ্গে আর 1 অ্যাড হয়ে 2 হয়ে গেল, মানে অ্যাডজাসেন্সি চেকিং, অ্যাডজাসেন্সি যদি ভার্টেক্সটা অ্যাডজাসেন্সি হয় তাহলে তখনই কি হবে না কালারটা 1 ইনক্রিমেন্ট করবে, যদি অ্যাডজাসেন্সি যদি না হয় তাহলে জাস্ট টু কন্টিনিউ দ্য লুপ। After that, the step 4. The step 4 is very simple. Step 4 and step 5. Step 4 is recursively called for next vertex coloring k plus 1, comma n. N is the number of vertices. And final step is return. This is the basic mechanism, and the display function actually display the procedure. definition. Display n number of vertices with unique color of adjacency vertices. The step 1, color, right color the vertices, and for I equal to 0 to n minus 1, n is the number of vertices. Do the right vertex I plus 1, because I start from 0, আমি পিন করব v1 v2 এরকম টাইপে পিন করতে চাইছি, সেই জন্য আমি ওখানে লিখছি vertex I plus 1 and color x is a resultant vector whose contain the color number, and just to the আউটপুটটা কি হবে না, আউটপুটটা এরকম টাইপের শো করবে। Display the color of vertices, the v1 equal to 1, v2 equal to 2, and v3 equal to 3, and v4 equal to 1. So how many number of color are used for color use? There is 3 color are used for coloring the graph, 1, 2, 3. The chromatic number only 3. The minimum chromatic number, যেটা minimum যে coloring numberটা হচ্ছে সেটা 3. This is known as the chromatic number. Okay. Now, what is the time complexity of the graph? The time complexity, the time complexity যদি আমি এই করি কি হবে? Now, this algorithm actually uses the recursive backtracking schema or technique. Okay. In this algorithm, actually, the how many number of vertices are there? N number of vertices. The how many number of vertices? The n number of vertices. Vertices. The total time required for a graph with n number of vertices by the number of colors. Okay, the number of colors, the time complexity of this algorithm. Complexity, time complexity is equal to order of n into m. N is a number of vertices. M is a color to the power n. N is a number of vertices. M is a number of color. Okay. Color to the number of color. Okay. To the number of color and a number of color and number of vertices are the same হয়, that means say m equal to n. In this situation, the time complexity, say tn equal to order of n to the power n plus 1. To the power n plus 1. Okay. This is the time complexity. Now I'm just to quick 2 minutes time নেব তোমাদের একটু এটাকে আমি একটা এমসিকিউ কোশ্চেন ডিসকাশনের জন্য। This is the MCQ question discussion session. Just the first question, আশা করি তোমরা দেখতে পাচ্ছ কোশ্চেন, the in how many direction do sorry এটা in queen problems, the question, the in how many directions do queens attack each other, do you know? কে বলতে পারবে? In how many direction do queens attack each other? Three direction: row, column, and diagonals. Row, columns, and diagonals. The answer is C. The second problem: they're placing n queens so that no two queens attack each other, each called n queen, 8 queen, Hamiltonian circuit problem, the subset subproblem. Very simple. N queens are there, n number of queens are there. That means n queens problem. And the third question: which of the problem cannot be solved by backtrack method? Okay, very important for the CA2 test. This type of question are there in the CA3 test. Which of the following which of the problems cannot be solved by backtracking methods? The n queen problem solved by backtracking. The subset sum problems backtracking. Okay. Hamiltonian circuit problem, so backtracking. Traveling salesperson problem, dynamic programming. Traveling salesperson problem. A traveling salesperson is a correct answer. Cannot be solved by backtracking method of this problem. Okay. This in n queen problem, how many values of n does not provide an optimal solution? কেউ বলতে পারবে? How many values of n does not provide an optimal solution? The 2. The answer is 2. In n queen problems, how many values of n does not provide an optimal solution? In value is actually option is B. Value is 2. 2 value. And that means say n equal to 2 and n equal to 3. This is a 2 value. Does not provide any solution. And n equal to 1 is a trivial solution. Which of the following methods can be used to solve n queen problems? The greedy method, divide conquer, iterative method, backtracking. So I know backtracking method. How many possible solutions exist for an n 8 queen problems? The 8 queen problem. How many solutions? Solution answer is 92. 92. The option C is correct answer. Option C is a correct answer. Okay. Now, say another question of the following given option. Which one of the following is a correct option that provides an optimal solution for 4 queen problems? There are 4 options are there. There are 4 options are there. A, B, C, D. Now, which one is the correct? The 4 queen problems to the the 3, 1, 4, 2. There is option 1 is correct. Okay. And the second one, of the following given problem options, which one of the following does not provide an optimal solution for n queen problems? There are 4 options are there. There are 5, 3, 8, 4. এটা তোমরা করে দেখলে বুঝতে পারবে. The first option is the solution. The second option is not a solution. Okay, it's not a solution. This is the correct option is B. C, D are the part of the solution. Okay. The backtracking algorithm is implemented by the constructing tree of choice called as the state space tree. Okay. And what happened when the backtracking algorithm reaches a complete solution? Complete solution. There are four options up there. The backtrack to the root, backtracks to the root, and the second is that it continue searching for other possible solution. This is the question number. Option B is correct answer. It continues searching for other possible solution. And the in this last problem, the backtracking algorithm is faster than the brute force technique. The two option true and false. Yes, it is true. The backtracking algorithm is faster than the brute force technique. And in what manner is the state space tree for a backtracking algorithm constructed? There are four options are there. Uh, Depth first search, best first search, twice around the tree, the nearest neighbor first. The option is the best first search. Best first search, the backtracking state space for a backtracking algorithm constructed the best first search, DFS. And what is vertex coloring of a graph? Uh, a condition where any two vertices having a common edge should not have same color. Yes, the first option is correct. The first option is correct. A condition where any two vertices having common edge should not have same color. And the mm, next problem, the minimum number of unique color required for vertex coloring of a graph is called the chromatic number. Option C is correct, chromatic number. And how many unique color will be required for vertex coloring of the following graph? There are four. The complete problem. And what will be the chromatic number for a complete graph having n number of vertices? The answer is n number of already this type of example is already discussed. They can complete connected. This graph is a complete connected graph. The n number of all vertex each and every vertex connected to the other remaining vertices. তাহলে যেখানে যদি চারটি ভার্টেক্স থাকে তাহলে চারটি ডিস্টিংক্ট কালার লাগবে সেরকম n নাম্বারের জন্য n নাম্বার অপশন সি ইজ কারেক্ট correct answer. And now just reference some video lectures set link are there in this slide. আজকে তোমাদের এখানে শেষ থ্যাংক ইউ তোমাদের ল্যাব আছে ওকে ক্লিক করে যাও